So here I'm doing trying to complete lesson unit 4, lesson number 11, and this is more about evaluating logarithmic expression. So I'm going to go directly to the practice problem here. First one. So let me see how far I can go to show these problems. First one is right here. So so select all expressions that are equal to plus. What is this? So logarithm a to the base 2 is asking a question. How many times do you multiply this? So what this basically means, how many times do you multiply to get 8? And you can see it has to be 2 raised to 3 is 8. So 2 times 2 times 2 times 2. So this answer is going to be 3, and you are looking up for which among this gives. So if you check the first one, if you want to figure out what is this answer, and if you do not know, we'll call it P. So that means 5 raised to P is 20. So this is exponential form, log form, and this is uh, exponential form. So now we do know 5 raised to 1 is 5, 5 raised to 2 is 25. Now this 20 is between this, right? So your answer has to be between 1 and 2. So it cannot be 3. So we have to get a 3, right? So this is wrong. So let's check the next one. If you see, the next question is log of, let's see, we don't know what is the thing, so I'll put it like a P. So the base is 5 here. So you pick the 5 and put the P as the exponent equals 125, and P has to be 3, right? Because if you put P, this is 3, then 3 times 3 times, sorry, 5 times 5 times 5 is, so that's correct. What about logarithm of 100? So log this one is how many? So this answer is straight away, we know 10 raised to 2 is, so this answer has to be 2 because, so let's try the reason, because 10 raised to 2 is 100. So we need to have 3, so this cannot be the answer. Now here, you don't know, put a P, so ask a question, 10 raised to what is 10,000, sorry, 1,000, and it has to be 3. So the answer P has to be 3. So this is correct. What about this one? So this one I'll put as a P. So the base is 3 here. So 3 raised to P is 27. And clearly P has to be 3. And that's the only way you can get 3 times 3 times 3, which is 27. The next one is, what about here? So basically this is 10, and that is 1 over 1000. See? And you're asking 10 raised to what? We know 10 raised to 3 is 1000, and 10 raised to minus 3 is 1 over 10 raised to 3, which is 1000. So the answer for this is minus 3, but we needed to get 3, so this cannot be the answer. Hope that helps. Well, let's go to the next. And the second problem is, which expression has a greater value? So is this bigger or is this bigger? So we'll do one at a time. So logarithm of 10 and 1 over, now there is a fraction, right? So if we know logarithm of 100, the base 10 is 2, because 10 raised to 2 is 100, right? But this is a fraction, so whenever there's a fraction, we put minus 2. Okay? The other one is logarithm of 2 1/8, and you can see 2 raised to 3 is 8, and 2 raised to minus 3 is 1 over 2 raised to 3, and that is 1/8. So that's why this answer is minus 3. So this has to be minus 3. So we're asking how many 2's do you multiply to get 1/8? And we say, hey, it has to be minus 3, see, this one. So this number and this number, minus 2 is greater than minus 3. So this value is bigger. So you need to give the reasoning. Let's go to the next question. So third question, Andrea says, this is log of 10 to the logarithm of 55 to the base is 1.5 because he says 55 is halfway between. Suppose this is 10 all the way to 100. So in between total is 90. So the students think that uh, this is 55 is between. So if you see 10 to 55 is 45 and 55 to 100 is also 45. And he thinks logarithm of, let's say, 10 to the base 10 is 1 because 10 raised to 1 is 1. And he thinks logarithm of 100 is to the base 10 is 2. So he sees this 10 and 100. So he goes, checks this is almost like a difference of 90 and he put 45 halfway down. And because it is half, and this answer is 1, this answer is 2, he says in between is 1.5, but that's not correct. So the right answer is if you see logarithm of 55 to the base 10, and if you check on the calculator, it will be 1.75, which is more closer closer to 2, this answer is. So let's see whether it's really true. So if I take the calculator here, I use the Desmos calculator, and I want to know where is logarithm. You can use your yellow calculator also and get. So if I click here, yeah, this is the one, see? And I put a 10 because the base 10 of 55, we get 1.74. So that's how it is, right? So that's what he's thinking is wrong. So you should explain why he's wrong. So this is the correct answer. So just because it is halfway doesn't mean the value will be one between this one and this one. No. So hope that helps. So here is a question: an exponential function is given this way, and the question is if x increases from 1 to 1.5, which is an increase of 0.25. See? And here also it says from 2.75 increase of again 0.25. The value of k grows by the same factor. So this is the name of the function is k. Instead of f of x, they give us kx. So that should not be any. So what we will do is we will put this value and this value. Okay. So and then take the remember when if you want to know some growth factor from one point to another point, let's say this is a and b, and if you want to know the growth factor from here a to b, this will be b of whatever that y output. So I'll call the output as, let's see, y2, and this one is a y1. So there are two outputs here. This is important, right? And to get the growth factor from here to here, it is always y2 divided by y1. So that's how you find the growth factor. Now in this example, we will plug this in this part to get the output. This is given, right? So the first part is we put k of 1.25. That's like y2. We want to figure out like a y2 and then divide by k, the output when it is 1. So when you plug this in 1 here, this will be 15 times 2 raised to 1.25 divide by, and then you put this one. See, so first you put this one, and then you put 15, and now you put 1. Now you can see 15 can be divides both numerator and denominator, so that goes away. So this crosses out, and what I will left with is this the numerator can be written as 1 times 2 raised to 0.25, and the denominator is 2, right? Or 1, so this also goes away. So you get a factor which is 2 raised to 0.25. And we can check for the second one here also. We'll start with the 3. So you do k of 3 divided by k of 2.75. So that will be 15 times 2 raised to 3 divided by 10 times 2 raised to 2.5. So I'm just plugging in uh, the 3 first. This 3 go right here. And then I'm plugging the 2 point, right? Now, as if 15 goes away, and you can use the quotient of exponent 2 raised to m and 2 raised to n, which is same as 2 raised to m minus n. So we can use that, which is 2 raised to 3 minus. And if you subtract, we get 3, 0 point, sorry, 2 raised to 0.25. And you can do the same thing. And that's why for the equal interval, so what we will learn is we prove that for equal increment of x, which is 0.25, and from here to also 0.25, the growth factor is also stays the same. The next question they're asking is to use theoretical type t is used from t. Let's see. So from t to t. So this is like t could be any number, and then that same number you add 0.25. So what you do is you put plug in this t plus 2 right here. So we put k of t plus 0.25 divided by k of t, because this is the t, right? And then this becomes 15 times 2 raised to t plus 0.25 divided by 15 times 2 raised to t. And you do the same thing like we did in the previous problem. So we can split the this one. So this 15 goes away, and the top one we can write 2 raised to t times 2 raised to 0.25. And then the down one is 2 raised to 3. This cancel get, and you get the same thing what we got right here, right? So it grows by the same factor. So hope that helps. So if you see here, there is a dollar one and it doubles. So the growth factor is 2. So when will that be 1 million? So you just imagine every day the dollar that you put doubles. So that means it's something like this. So in the beginning you had $1, and let's say this is number of days, like when you had number of days, and this is the amount. So in the beginning you had 1 day, 2 days, 3 days, 4 days, and likewise 5, 6, and 7. And you want to know when will this be 1 million, right? So one thing I don't know is if I multiply 2 once, it becomes 2, then 4, then 8, and you multiply it to become 16, 32, 64, 128, 256, and 512, yeah, like this. So 8, 9, and until 10. So until 10 will be, if I take the next one, 10, this will be 1024. And you want doing, you will see 2 raised to 9, and you can always check with the calculator. You say 5, 2, 4, 8, 8. But if you multiply one more time, 2 raised to, let's say, 20, that will cross this is like almost half a million. So this will be more. I'll just skip this and I'll use this. So this will be 1,048,000, see, something like this. So which will be, let's see, more than 1 million. And you can check with the calculator also. See, if I put 2 raised to 19, see, you get that. And if you put 2 raised to 20, see, this is almost like 1,048,000. So that's how it is. So you can see that's what they're asking us. Explain how you know. And if they you did this, you can always see you just multiply 2 continuously like that. So basically, you're asking 2 raised to what gives you 1 million, right? So if you really want to use the logarithm, then we say, okay, I don't know this, so let's do that. So we say logarithm of 1 million, we put to the base 2 and we get the exact answer. Okay? That's how the log helps. So if you go to here again and get back at your log, okay, and I put log of to the base 2, and here you put 1 million, okay, and you get 19.3. That's exactly like 19 days and something like that. So hope that helps you to understand how log helps us to. Of course, this was lesson number unit 4. It's just a practice problem with what you do. If you miss something, you can always get back like to that old lesson. So that's why I'm trying to walk through all of them. So yet again, this is unit 4, and I think this gives you lesson 8 back again. What value should be question mark? See the first one, logarithm of 10, and when do you get 10,000? So you're asking a question. When 10, this base 10 raised to what number gives you 10,000? And the only way it has to be 4. That's the only way you get 10,000. It's so simple. So the answer of the first one is 4. So simple. What about the next one? 10 raised to what number gives you 10 million? That's what you're asking. Correct? So how many zeros are there? 3, 3, and 5. So the answer is 5. And you're done. What about the next one? So you're asking for this one. You're saying, okay, 10 raised to what gives you 5. Now this is a tricky question because we know 10 raised to 1 is 10. And 10 raised to 2 is 100. And 10 raised to 0 is 10 raised to, sorry, 10 raised to 0 is 1. Anything raised to 0, anything raised to 0 is 1, right? So you have a 1 and a 10, and this 5, which you have, they gave us here. See 5, this black one? This 5 is between 1 and 10. So 5 is between 1 and 10. So that means your answer has to be, so the value has to be 0 and 1. So the answer has to be between 0. So you need to have a value which is between 0 and 1. That's what you're trying to figure out. So you just have to say, okay, just wanted to know, let you know, here I made a slight mistake. I took a wrong kind of this one. I presume that this was 5 and that was the question mark. So I know, and I'm sorry about it. So this was the question mark. I'm just taking two different scenarios of 3. Let's imagine since I showed this work, all this work is what if it was log of 5 to the base 10, then all this work, the answer will be between 0 and 1. But I hope this helps. So it's like working on two things at a time. And now let's do the one that is actually given up. So this one, this example that I did was, okay, let's go back here. Uh, so they ask what is logarithm of what? I mean, this is straight away question, right? So 10 raised, so how many times should we multiply 10? But then they already, this is the question. So you just have to put 10 raised to 5. That's all you do. So it becomes 3 zeros here and 2 zeros here and done, 100,000 done. So this answer has to be 100,000. So it's a very easy question they asked. But I was trying to show the other one if it was log 10 and if the 5 was here and then what's the question? So I was trying to say, hey, if that's the question, 10 raised to what gives you 5. So anyway, you learn both things, both these three things together. And the last one is what is this? So logarithm of question mark here, and they put 10 is 1. Basically, you put question mark is 10 raised to 1. And 10 raised to 1 is 10. Is it done? That's all it is. So this answer. So the only way you can get this is log of 10 to the base 10. One more thing you see is whenever these numbers are same, you always end up getting 1. It's like, so if we have logarithm of 2 and to the base 2, answer is 1. Logarithm of 3 to the base of 3 is 1. Logarithm of 5. So anytime we have the same number, it's always going to be equal because 5 raised to 1 is 5. 3 raised to 1 is 3. 2 raised to 1 is 2, and that's it. So if you see this value of t will make this thing true, right? So let's say if it is 2 raised to t, this is in the exponential form. We can change it to logarithmic form and they ask logarithmic of 6 to the base 2 is question mark t, right? It's the same thing. Now, we don't have to go too much into that. We know 2 raised to 1 is 2, 2 raised to 2 is 4, and 2 raised to 3 is 8. So now this 6 which you see right here is between this 4 and 8. So 6 is between 8 and 4. That means your value should be, this t has to be between 2 and 3. That's it. Because if it is 2, you get 4. If it is 3, you get 8. Then anything between 2 and 3 will be giving anything between 4 and 8. That's all it is. So which two whole numbers? The whole numbers are 2 and 3. You're done. If you see, either you can say here also, this is the value which will make it true. That's the right way to do. But the second question is asking between which two whole numbers between 2 and 3. Okay, this one is given in the exponential equation. You have to write in the logarithm. Okay, and remember the easiest way to do is if a is b raised to, let's say, some x, that means logarithm of a, because this is the base that goes down equals x. So the first one, if this is the case, 3 raised to 4, it means logarithm of base is 3, so 3 goes down of 81 and equals 4. So it's the same thing, see? The next one, logarithm of base is 10, there's 10, and of 1 is 0. So these are called writing in the logarithmic form. This one is you write logarithm of 2 here, and the base is 4. Answer is half. This one is logarithm of 5, base is 2 equals t. And the last one is we have m raised to n is c. So the base is m. So I'll put a logarithm, but down one is always the base. And this output becomes your input. And this how many times becomes the output. We're done. Hope that helps. So I hope please do write all these steps so you get 4.